Hey, what's up? So the first thing that I notice about the daily problem is 36.1% acceptance. Now that doesn't mean people that start trying the problem only 36.1% get it right. It means that they submit the solution and then a majority, a pretty big majority actually, fail the system tests. So there's probably some sort of hidden complexity here. Or maybe it's just a shitty written problem. That's possible too. Alright, you're given an m by n grid. A robot starts at the top left corner of the grid, 0, and wants to reach the bottom right corner, m minus 1, n minus 1. The robot can either move right or down at any point in time. Trivial. The grid contains a value, coins ij, in each cell. Okay. If coins ij is greater than or equal to 0, then the robot gains that many coins. If coins is lesser than 0, the robot encounters a robber, and the robber steals the absolute value of coins ij coins. The robot has a special ability to oh my god. Okay, it's sounding less easy now. The robot has a special ability to neutralize robbers in at most 2 cells on its path, preventing them from stealing coins in those cells. Note, the robot's total coins can be negative. Return the maximum profit the robot can gain on the route. Okay. It sounds to me like case for memorization. So LRU cache none, and then we'll say def RI comma J like that, and oh wait, and remaining neutralizations, I guess N, I don't know. Yeah. So that's that. Okay, on the last cell. Okay, the coins can be negative, so yeah. So if I is greater than or equal to length of coins, then return negative. What's the max? Yeah, so. Yeah, so in other words, we're not messing around. Or J is greater than or equal to length of coins of 0. Okay, that's if we go out of bounds. Yeah. Now, if I is equal to length of coins minus 1, or J, not or, and J is equal to length of coins minus 1, right? So in other words, if we're in the bottom corner, yeah. Well, let's see. If coins ij is greater than or equal to 0, then simply return that. Okay. At this point, there is no reason to not use a neutralization. Yeah, so we will say assert n is greater than or equal to 0. Now, otherwise, we're here. So if n equals 0, then return coins I comma j, because that's going to subtract. Otherwise, we can neutralize. And what happens if we neutralize? Neutralize, preventing them from stealing coins in those cells. So yeah, return 0. So if we have a neutralization in the bottom right corner, then we're always going to use it. Yeah. So all of these paths return, all of these paths return. We don't need to use else if. Okay, so if it is positive, okay, then we're gonna have value well, hold on. If it's positive, then we don't really want to, well, there's nothing to do with it, is what I'm trying to say. So return this, and then this is going to be the recursion step, plus ri plus 1 comma j comma n. We want the maximum of the two different paths, right? Yes. If coins I of j is greater than or equal to 0, or n equals 0, yeah, then we don't really have a choice what we're going to do. So now we know that it is less than 0 and n is greater than 0. So we have a choice of either using it or of not using it. So choice use equals pretty simple, except that n is going to deduct by 1, and choice, I don't know, take the loss, let's just say not use, equals, well, yeah, it's the same. So, and then we just want whichever the best is. So, all right. We can neutralize it most 2 times. So we're going to say return r0, 0, 2. And that should give us the answer. List index out of range. Now, you know what? That is just making me sad. Print length coins. Print length coin 0. Do it like that. For hell's sake. Alright. So, what in God's name? Alright. You okay there, Luke? I don't know what the hell happened. Sorry. Should we need that? Alright. Write and submit. Now we'll see if there's some edge case that catches us. Oh, here we go. What is going on? I didn't expect to get through 457 test cases and then fail one of these. So, number 457. Did we miss a requirement? You are given an m by n grid. A robot starts at the top left corner and wants to reach the bottom right corner. Easy enough. The robot can either move right or down. The grid contains coins ij. Is there some missing requirement here? Neutralize robbers in at most 2 cells. Did I not deduct it or something? No, I did. Something very odd is going on here, and I bet somebody knows. When the next cell direction involves either right, down, or left up, it's usually dynamic programming. When the next cell contains both right, down, that's usually breadth first search. Yeah, we get a collab of dumb robots and smart thieves. Come on. There's got to be some sort of a hint. Test case wrong. Let's see if we can figure this out. I don't know how we're going to figure it out. I mean, this is a pretty simple problem, right? If we go out of bounds, then return this. If we're in the corner, if n equals r, what in the hell? N equals r? If n equals 0. What a stupid mistake. You know, that's not fair. I mean, if I missed it for a legitimate reason, oh, for hell's sake. That is a lot of friggin' zeros. Okay. Can we ever repeat a cell? Yeah, you could. But how many actual different variations are there? There's quite a few. What a pain in the ass. All right. Yippee-ki-yay. So best cost equals so it's going to be 0 for I in, it's the inner one, so range length coins 0, and then outside I think we can do it like this. For I in range length coins. And then for N in range 3. Right? Did I do that right? So for I in range length coins, I need to make sure that I did this right. Let me just say, I think I may have done this wrong. Maybe that's the way that I should put it. BC of 0 of I of j equals coins ij. And this will give us an out of bounds if I screw something up. Okay. So there is no way to be at n. Yeah. So let's have it be negative like that. And then BC of 2 of 0 of 0 equals what? Equals well, just coins of 0, 0, right? Yeah, and then if coins 0, 0 is less than 0, then we also have the option of BC1 equals just 0. That's the neutralization step. Now we should just be able to go across each row and then pull from above. Do we want to calculate the first row first so that we don't have to check? I don't think it really matters. What the hell? What the hell? Let's do the outer layers. So for I in range length, coins 0, and by convention this is j instead of I. So this is going along the top, but we don't want to start at 0, we want to start at 1. So we need a way to join the cells. So we're going to say def, I don't know what to call it, P, and then it's going to have an origin point and a destination point like this, so we don't have to repeat the logic every damn time. So yeah, so current cell equals coins I j, right? And if current cell is less than 0, we're going to say best equals this. So if current cell is less than 0, then we need to look at the n values that are available. And I think that there are always n values available. They're just not valid because they're negative. Do we really need to see if it's negative? Does it matter? I don't think it matters. So let's call it NN. New N in range 3. We have the choice of not applying the coin, or of pulling from a higher one. Yeah, so best equals max best. Yeah, and it's going to be, so this is the same. It's BC of NN of, I've got to stop making these stupid mistakes. X, Y, plus current coin, right? Yes. And then if NN does not equal 2, then we are also going to check this. We don't need any special math because the max will take care of it. So this is going to be the origination plus 1, and we're using the whatever it is. So yeah. And then when we are done, we will simply say nn in range 3, we have to start with the existing best, right? Which is going to be BC of nn of I, comma j. Right? Yeah. That's where that value comes from. And then we can reuse the method from different places. And then when we are done, when we have compared this and this, then we can set BC of nn of I, comma j is equal to best. So either it's what it started as, or it's this, or if nn doesn't equal 2, then we have the option of doing this. Yes, okay. All right. Well, that was pretty easy. And we only use CC once, so this seems kind of stupid to have it in its own variable. All right, now, as we are going across the, sorry, I'm from Utah, across to the right, we won't be pulling from above. So it will simply be P of 0, comma, should it be Y? Seems like it should be YX, not XY. Whatever, I don't care. The origination is going to be 1 less, and then 0, comma, J. Like that. And I will be pretty similar. Like this. Probably didn't need to copy that. I 0. Well, I negative 1. I, comma 0. All right, and then after that, we can just pull from both. So I don't really think it matters which order we go in, but just by convention, I is the outer loop. So, all right, now we just have to do double, because it can go right or it can go left, right? Here, let's type these. I, comma j, I, comma j, and then this is going to be like this. Okay. Shouldn't have used memoization. I really didn't expect it to memory out like that. Okay. Now, once we are to the bottom, then we simply return max of BC of, well, let's not do it like that, for n in range 3, n, and negative 1, negative 1. Bottom right corner. Okay, right, and submit. Phew. All right, so